Good morning all of you. Today we will see some basic operations on signals. We perform these operations on continuous time signal and discrete time signal. Continuous time signal we are considering as x of t, and discrete time signal we are considering as x of n. Here we are considering a one-dimensional signal. That's why the signal looks like this, x of t, where x of t is our dependent variable, and t is your independent variable. Same thing applies for x of n also. In x of n, x is dependent variable, n is independent variable. X is dependent variable. Okay, we'll write any signal x of t. The signal depends on t. Okay, here t will vary. Now we will see amplitude scaling. Amplitude, that means magnitude of signal, can be changed with amplitude scaling. Here the continuous time signal is a x of t, then c into x of t is a signal after amplitude scaling. Here c is your scaling factor. Okay, now we will see some amplitude scaling examples. Okay, here this is x of t. Now if I want the signal 2 into x of t, then the signal will be like this. Only amplitude of the signal. Initially the amplitude is 3, now the amplitude becomes 6 because of the scaling factor 2. Here the scaling factor is 2, so the amplitude is 6. But the time axis remains the same. If in the same signal, if I want 1 by 2 into x of t, the amplitude now, the scaling factor now is 1 by 2. That means the amplitude of the original signal will become 3 by 2. That's it. The signal time remains the same. The signal. This is amplitude scaling.